Our first setup for today is this. You got 50 meters of fencing. It's your job to make the biggest garden possible. So what measurement are you looking for if we're saying biggest garden?
Length and width.
Well, length and width matter. Area, okay? So start on your notes by drawing like 2 or 3 rectangles. That could be the garden. Your goal is biggest garden. Do you need to know the answer to start? No, there is a biggest garden dimension. So you're going to try some dimensions out. Okay? So there is a right answer, but you maybe don't know it. Maybe you need to try a few gardens to see if you can find a pattern. Let's go. All right, friends. Let's look at some gardens. So if I know I'm drawing some rectangle gardens and I want to try to get, the most area possible, I'm going to do like a long skinny one, maybe a medium one, and then I'm going to do a square. Yeah, I'm really good at drawing rectangles. So let's say this one would be 1, 1, 24, 24. Okay, what's the area of this garden? 24 square meters. Okay, what happens if I had a 15, 15, 10, and 10? What's the area of that?
150.
So I got bigger by squishing together more. Let's try 12 and a half by 12 and a half. What'd I get?
156.25.
And that's the biggest we can get. Because once I change my length, it went let's say it went 10 to 12 and a half. Once I go bigger, what's getting smaller again? The side length, right? In fact, if there's a 1 by 24, there's a 24 by 1. Now, fun question. If the square gives us the most area, why are there so many rectangular gardens out there, do you think? Micah?
Probably just because there are lanes of...
Yeah. If you have this big old square, it's hard to get to this stuff in the middle, isn't it? So, they're less efficient than they could be, but it's kind of more practical that way. Take a look at these different gardens. We're going to do, I suggest to you in your notes, we're going to do a length, width, and area table. All right, because do you notice that we have length for the input and then area for output? So on our rectangles, when the length was 1, what was our width?
24.
And our area was 24. The next one we looked at, we did 10 by 15, is that right?
Yeah.
And our area was 150. And then we looked at a 12 and a half by 12 and a half. And that one was 156.25. And we said that's the most. What about a 15 by 10? 150. What about a 24 by 1?
24.
Check out these outputs. What are you noticing can happen?
Parabola.
It's a parabola.
Parabola.
Parabola. But are you noticing that our outputs repeat themselves there? Yeah. That's because it's this type of function. So let's graph these. I got 124 right about there. 1015. Or sorry, 10 150. 12 and a half. 150. 6. Something like here. 1510. And 24 1. And you guys are correct. It is a parabola.
It's a parabola.
Soldier Boy's favorite, baby. Some fun things. This right here is called the vertex, and it, in this case, is the maximum. And there is a fun fake line called, not fake, but it's not like actual line. This is called the axis of symmetry.
Yeah, we did that in the one class.
Yeah. So notice this and this are mirror images of each other. So that's just some fun language that you're going to see coming up this unit. So why do both of these points work? A 3 by 22 and a 22 by 3. Why do those both work, Micah?
Because... Wait, 3 by 22? It says 3 by 66.
No. Length of 3. Area of 66.
Oh, because the...
So there's a 3 by 22, and then there's a 22 by 3. Why do they both work?
Because they're equal to 50 and...
They both have a perimeter of 50,
Yeah.
yep. And the length and width are switched.
Right.
That's why they're on the parabola. Raymer.
For the graph, isn't that last point you put, it looks like it's at 24, 24. Wouldn't it be at... Oh, no, wait, never mind.
24, 24. It should be at 20. Yeah, it's length and area are two. Yeah, you were looking for 24, 1?
Yeah.
Yeah, I get you. Now, could 125 work? Does 125 work?
No.
No, why not?
That would be 52.
Yeah, if I have a side length of 1, what would the other side length have to be?
24.
It have to be 24, which is an area of 24. Length times width, base times height. Okay, Asher.
There's a little bit.
So again, the two big ideas, the answers repeat. The other big idea is how do we maximize the area of a rectangle? What shape?
U.
No, how do we maximize the area of a rectangle? What shape did we end up with?
Square.
A square. The same side length squared.
What is the
Also known as, whatever it is, squared. That's the most it can be.
is
So with that, we're going to finish up the first part of the lesson. You are going to move. So you got notes you can write on. It matches things in Desmos. So student.desmos. You're still going to work with your partner, but everybody's going to do it. Go to student.desmos. When you get on Desmos, you'll see this page. And you're going to notice there's 4 expressions. I want to know, you're going to pick the one that you see. Which expression do you see there? So you look through the expressions, or actually what I would start is looking at that picture and being able to describe what you see, the shape. And then look for the expression that matches what you see. Okay, so I'm just going to draw what I see first. What I'm inclined to see is this and this, which would be a 5x6 and a 3x4. Raise your hand if that's what you saw. Okay. My second inclination is to see this whole thing take away that chunk,
That'd be the 6.
which is right here. Raise your hand if that's what you see. Okay. I'm less inclined, but do see a 4x4, a 4x4, and a 2x5. I would change the 10 to 2x5 for me, but everybody seeing that? Even if you didn't pick that? Who picked that one? Anybody? No? And then this top one is 5, 5, 8, 8, 8, 8. Raise your hand if that's what you saw. 5, 5. Yeah. What's cool is, guess who's right? Everyone. And that's because math is creative. All right? So next, you're going to go to this page. And you're going to just, in words, explain how you see this changing. So S stands for step. We're going to call this step 1. Step 2. Step 3. So you're going to explain how you see this changing. Look for motion, look for movement. Use your own words. Let's go. I'm interested in hearing how you see this changing. How do you see it changing, Tess?
The length and the height and the area.
Okay, so that is changing. All right, can you give any specifics as what you see happening as you go from one to the next?
Getting bigger.
Okay, it's getting bigger. Ellie.
The area is changing every time.
The area is changing every time. Okay, Micah?
I noticed that the base layer is increasing by 1.
So it went from 3 to 4 to 5 on the base?
Yeah. And
Okay.
It looks like the area seems to be it goes up by 40%.
Huh, 40%.
Sorry, it goes up by 100%, and then it goes up by.
No.
I'm not getting the same change over and over. Elliot, what are you seeing?
I'm seeing that it's going up by 3, then it's going up by 4, and then it's going up by 5.
3, 4, 5. Okay. It's asking what do you see staying the same? What do you see staying the same as it changes? What do you see staying the same, Emmett?
There's always at least 3 blocks on the.
You seeing these 3 blocks? Okay. I'll tell you what I see. I see this block here and this block here staying there and getting pushed out. There they are. And then look what shape I see in the middle. Square. Okay, so I'm going to see those 2 get pushed out. Look what I see in the middle. That's just what I see. It can be different than you. All right? So next up, you're going to build what you think the 4th step would be. So I'm going to explain. Remember I said I saw these 2 on the outside and then the square in the middle growing?
Yeah.
Notice 1 square, 2 squares 4, 3 square is 9.
Oh, and I noticed that it's
So 4 square is going to be 16 in the middle here. Oh yeah, boom. Uh-oh.
Oh,
Nope.
no.
And then these two, remember I saw those two getting pushed out? It's the moment of truth, or the MOT.
You're too high.
Whoo! Let's go.
Mr. Mac, I also noticed that it went from 0 on the top layer to 1 on the top layer to 2 on the top layer.
Oh, so you're looking top layer.
Who's off again?
Okay, I want to know step 10, how many are there? Okay, y'all, so here, remember, here's what I see. I see a 10 by 10 happening and those two more, which would be how many?
102.
Cieni dos.
This next part is complete.
Let's check it. Let's go. All right, next up. What type of function do you think this is? So I'm going to teach you a little something extra right now. Y'all said something else, right? So check out, there's something cool here that happens with the quadratic. See how it goes like +3, +5, +7, +9, and so on? What are you noticing about the difference?
They're all odd.
The difference is increasing by 2. It's not increasing by 2. The difference is increasing by 2. But there's this thing that happens with quadratics. It's called the second difference. 3 to 5, 2. 5 to 7, 2. 7 to 9, 2. 9 to 11, 2. What do you notice about the difference of the difference? Samesies. That's kind of fun, eh? I gave that to you extra. That's not even in the lesson. You can have that one for free, okay? So there's going to be a new pattern. I'm actually going to open the rest of this up. You're going to finish this independently, but working with your partner. I know those two words don't make sense together. Everybody's doing stuff on there, but you're talking with your partner, okay? There's one that asks for a worksheet. You do not have the worksheet. You can just skip that one. And then we'll reconvene all together to look at the cool down in a little bit. So y'all, what shape are we looking for with quadratics? A square. So I like to write right on there. There's a square here, there's a square here, there's a square here. So S is like the number of steps. So I know I've got an S squared. There's our square. Now how am I getting the other chunks?
The side length times 2.
The side length times 2, so 2S. 2S is 6, 2S is 4, 2S is 2. Awesome. So for the fourth one, this one says click. I'm just going to draw it because I'm in annotate mode. My middle square is going to be what by what? So I'm going to go 4 by 4 here. And then I'm going to add, how long are these going to be? 4 by 1 and 4 by 1. And that is a quadratic function. It's this function. Here's my side squared. Here's my 2 steps, 4 and 4.
I'm still on slide 2.
Nice. Oh, someone is on slide 2. I'll tell you who. No, I won't do that today. All right. I'm going to get the homework going for you. There's 2 of them. You're going to do the odds.